This is a demonstration of the SimpliVity interface. All management of the SimpliVity environment is done through the vSphere client and is enabled through a plugin within vCenter. We're starting here on the London vCenter server. On the SimpliVity tab, you'll see that we have our federation displayed here. This federation is made up of the London and San Francisco data centers, each one containing a certain amount of free space, used space, and total capacity. Time zones are tracked, as are the versions. Upgrade status is displayed here on the right. Completing an upgrade is as simple as selecting Upload Upgrade Package, uploading the package, and running through each host. On the bottom left of the vCenter interface, you'll see another view of the entire federation, consisting of the San Francisco and London data centers. On the right, you'll see the policies that we use to manage the system. Each of these policies are configurable and can be created by the customers individually for their own needs. Each policy is made up of a series of rules, assigned to specific data stores, and/or virtual machines. A virtual machine will automatically inherit the policy that is applied to the data store that the virtual machine resides on. Rules are easy to add. By clicking on the policy, we can come in here and we can see all the details of the different rules within that policy. Creating a new rule is as simple as defining the frequency of the backup, how often the backup is going to be retained for, and which data center we want it to be retained in. For now, we're going to cancel out of this and look at the existing rules. Here we can see 6 different sets of rules. Each policy exists across the federation and could be applied to a VM or data store in London or San Francisco. Each rule defines which data center the backup will be stored in. The way this policy is configured, every VM will be backed up locally and remotely every 24 hours. Every day there's going to be a backup taken and retained for 31 days. Every Sunday there's going to be another backup taken that'll be stored for 90 days. And the last day of each month, there's going to be a backup taken and stored for 730 days. There's also the option of doing application consistent backups, none of which are checked currently. This uses the standard VSS driver within Windows. New policies are easy to create by dropping down this menu and selecting a Create Backup Policy. Now let's move on to the data center view. Now you can see the SimpliVity view of the London data center. We're no longer seeing the full federation, just the London data center. Starting over here on the right, we can see the total physical disk capacity of the data center. This includes all OmniCubes or OmniStacks that exist within that data center. Currently within this data center, we've used 8.1 terabytes and have 20.7 terabytes available. This adds up to a total of 28.8 terabytes of physical capacity available on this 2-node OmniCube data center. Over here on the left, you can see the logical usage of data. We currently have 19.5 terabytes of virtual machine data written. This is the data that vSphere is tracking from the actual running VMs. Just from this alone, you can see that 19.5 terabytes has been stored in 8.1 terabytes. In addition to the VM data, we're storing a total of 1.2 petabytes logically of local backups. These are backups that have been taken within the London data center of London VMs. The last bit of data that's being tracked is 47.8 terabytes of remote backups. These are backups that were taken from San Francisco VMs and stored in the London data center. Through all of that, we're getting a deduplication ratio of 110.8 to 1 and a compression ratio of 1.5 to 1, giving us a total efficiency of 161.7 to 1. This has resulted in a savings of 1.27 petabytes, while only using a little over 8 terabytes. Also in this view, you can see the list of all the virtual machines within this data center, and some performance metrics about what's going on within this data center. Scrolling down further, we can see the list of data stores and the list of all the OmniCube systems that exist within this data center. Next, let's take a look at the virtual machine level. In this view, we can see the breadcrumb trail that's led us to the specific VM. We can also see which policy has been applied to this VM, and actually have the option to change it. It's as simple as selecting which policy we want and clicking the Set Policy button. We can also see some statistics about the virtual machine's configuration. All of these stats are brought in directly through the vCenter interface. Next, we'll look at the list of backups that have been stored for this virtual machine. We can see the exact time that they were taken, whether or not they were taken with an app consistency, whether they were coming from a policy or a manual backup, whether this VM is protected with the backup, which data center this backup was stored in, logically how big this backup is, if the backup happens to be a remote backup, how much data was sent across the WAN for that point in time. In this case, we could see San Francisco is the remote backup, and only 17.53 megabytes was sent across the WAN. For the London backups, there was 0 data transmitted, because they're local backups, and therefore no data went across the WAN. Finally, we can see when this backup is going to expire. The last section here is more performance counters specifically for this VM, showing us both read and write activity, and the ability to change the timescale which we're showing this data. Now I'm going to demonstrate some of the SimpliVity tasks that can be completed against a virtual machine. By simply right-clicking on a virtual machine, we get a list of different tasks that are available to us. We'll start by doing a manual backup of a virtual machine. When creating a manual backup, we have the option of either providing a specific backup name or letting it auto-generate a backup name. Then we can choose where to store this backup. If we had AWS configured as part of the SimpliVity Federation, we'd have Amazon as a list within here. For this demonstration, we're going to create a local backup. You'll notice a SimpliVity specific task is created. These tasks are added as part of adding in our plugin. Already this backup has been completed, and it only took 7 seconds. This is a full backup of the virtual machine, but it was created by simply creating a copy of the metadata. There was no data that was read or written to the system. Therefore, no I/O was incurred. By refreshing the backups list, we'll see this new backup that was created. The big difference being that the source is now manual instead of policy, and it never has an expiration date, because manual backups never expire. Deleting this backup is as simple as right-clicking on it and selecting Delete Backups. And now it's complete, having taken only 2 seconds to delete that backup. Next, SimpliVity has the ability to create clones directly off the storage. Like a SimpliVity backup, a SimpliVity clone is simply a copy of metadata within the system. All we need to do is choose what name to give it. In this case, I'm going to give it the name Demo so that we can easily find it. This clone can be taken while the VM is powered on and running, and does not require the VM to be shut down. Again, another SimpliVity task has been created, and is now complete, having taken only 14 seconds to complete this clone. One additional task was completed, to register the virtual machine. Once SimpliVity created the copy of the metadata, it represented it out through the NFS store so that ESXi could see it. vCenter then needed to be told that the virtual machine was there and to register it within the list. We can see here that our demo virtual machine has been created. Now we're going to simulate the failure of the London data center to show how you can restore virtual machines. First, we go to the San Francisco data center and select View All Backups. From this list of backups, we need to find the virtual machine that we want to restore. We can choose to either filter it using the filters at the top, or we can simply scroll down until we find the proper VM. In this case, we're going to restore the 04 Win02 LDN server. Notice what time it was backed up. We could choose whatever time we want based on the list. To restore, simply right-click, choose Restore Virtual Machine. We could choose to replace the existing or to create a new one. In this case, we'll create a new one. We'll put Demo at the beginning of the name so it's easy to find. We could choose which data center and which data store to restore to if we like. In this case, we're going to keep San Francisco because London is down. Then click Restore. We can see now that there is a new task created to recover the virtual machine from a backup. And already this has been completed. It only took us about 20 seconds. There is one additional task that got created to register the virtual machine, which we can see up above here. Now we can power on this virtual machine and use it as we normally would. In a DR scenario, we'd power it on and users would start using the application. Let's say that they used it for a couple of weeks before we were able to get the London data center back up and running. In that case, there would be data resident on that VM that we would want to save. Once London's brought up, we have the choice of being able to restore a backup that exists within London and replace the existing VM, but in reality, we really want to keep the data that's on the one running in San Francisco. In order to migrate this VM from San Francisco to London, we simply need to right-click it and choose to move. This operation must be completed while the VM is down, but you'll see here in a second that the operation runs extremely fast and will result in very little downtime. On the Move Virtual Machine window, we can choose to select a new VM name if we wanted. In this case, we'll leave it the same. We can also choose which data center and which data store is going to be moved to. One last note to let us know that the VM must be powered off. Now we have another SimpliVity task for doing the move. During this operation, San Francisco is sharing a list of the blocks that can be used to recreate this VM over to the London data center. The London data center then reviews what blocks it has currently written and determines which blocks San Francisco must send over to London in order for London to recreate the VM. San Francisco must then only send the blocks that London does not already have across the WAN. This saves a lot of time and a lot of bandwidth across the WAN link. Our task is now complete, and took less than a minute to migrate that entire VM from one data center to another. If we scroll to the right here, we can see that the demo VM with the restore name in it has been moved over from San Francisco to London.